Okay, so the title of this presentation is the Berlin families. I think you'll understand that after we go through a little bit. But after titling it, it made me think of my own family. So here's a little tangent, just one slide. This was about 5 years ago. You can't read it from there. If you spent half as much time paying attention to me as you do studying that sculpture thing, you would understand me a whole lot better. I was spending a lot of time back then, and then.
How old was she at that time?
So that's the one back then. 5 years ago, she would have been 43. I would have been 45.
That's your wife?
That's my wife.
Okay.
Yeah. And so about 3 seconds later, this is what went through my head. At 1,000,000 against, the odds of me ever solving K4 are still 1,000,000 times better than the odds of me ever understanding it. I did not say that. What I said instead was, "You're right, dear, I'll do better." So, and I have done better. I've spent a lot less time on that. So I think that there was a breakthrough back in March of 2013. This was about 6 months before the last Kryptos get together. But first we'll mention that was a quote from you in Wired magazine, Ed. You need to solve the technique first and then go for the puzzle. Well, for the life of me, the only way you're going to solve the technique first is there's going to have to be clues, especially if it's a stacked thing like you're mentioning. There's going to have to be clues on or around, and based on those clues, you're going to be trying a bunch of things like we all have, and then finally notice something that's noteworthy. Well, after the clue of Berlin was released, and I think you guys were intending on us to find that and then work from there, but we didn't find it, so finally you said, hey, look for this word in this spot. March 2013, Scott Perry, a member of the Yahoo group, said he made a breakthrough using only characters carved next to one another on the sculpture and numbers found in the plain text. He obtained Berlin in the right location, and he only used the same two methods that you've seen already in K1, K2, and K3. This is phenomenal. So let's show you what that method was. So this is still what Scott said about two and a half years ago. His first thing was he did the same kind of thing as K1, K2, a Quagmire 3, using the very first 11 characters in the upper left, the Ima Fulzerurfa. And the reason why I think that's also kind of indicated maybe some little clues for this step. K2 mentions, hey, they use the Earth's magnetic field. Well, in E&M, or electromagnetism, the Greek letter mu, pronounced mu, is used to represent magnetic permeability. So EMUF might equal Earth's magnetic field. Maybe a little bit of a clue there. Not sure about that. There's references in K3 to the upper left-hand corner. Not a bad idea. And the arrow on Jim's worksheet, now this is an eye chart for you, but this thing can blow up to 101 inches. 100 inches. It's a great projector.
I'll pull it up here. How's that?
Jim's crib sheet. There's a little arrow just pointing right to the character's EMUF. You might wonder, yeah, that one. See the arrow right there? So I kind of like that, but what's really good is he just takes K4, does a Quagmire 3, and the key is the first 11 characters you see on the sculpture. Very nice, so I can still use
Where's the arrow pointing to?
Oh, really? Is it going to do that if I don't change it every now and then?
Okay.
Battery.
Overheat.
Yeah.
I think you wave the watch switch to turn off. I'm not sure how that works.
No.
There you go.
Maybe I have to keep it going or something. Anyhow.
Oh, it's on the other one?
Okay, I'm going to try to go a little faster because you need me to anyway.
Yeah.
Okay. First 11 characters, just do a Quagmire 3 on all of K4. And then the step 2 is do what I'm calling a skip decrypt, similar to what you might do to solve K3. Go every 192 characters, right? But that's not really the way it's implemented, but you can. In this one, Scott said, well, after you did what you just did with the Quagmire 3, start at the 77th character, which is 77 degrees west, and skip every 38 characters until you're done. It's the 38 degrees north, 77 degrees west. And if you do that, I think that thing's just gonna overheat.
Yeah,
This is
said
unfortunate.
something about heat.
Yeah, this is
Maybe move it
unfortunate.
up on top of the
Sure,
paper
it's
or
not
this or
kicking the plug
something.
out to keep us from seeing it.
It's turning itself off,
Put this
Put
next
it,
to
put
it.
it on top of it or something. See.
you think? Okay, can someone
This is nice and cold.
Can someone do that for me? I'm very poor at that kind of thing. At
What are
aiming.
we trying to do?
Set that up on the can and then aim
I
it at
think if you
the.
flip that,
Talk about
that
low tech cooling
upside
system.
down, that would be the
Yeah.
best, because then it'll be cool underneath of it instead of trapping
So the
it.
Coke can's a heat sink.
Got another an open port
I
inside.
think that'll work.
How much did you pay for that thing?
Well, essentially zero because I can just give it back within 14 days.
Yeah, you
I don't
might.
like it. Yeah,
How many lumens? Do you know?
like 200 or something.
Yeah, it's not very much, but close like this.
Okay, so, yeah, just, actually, let's go back one. So if you do that, you get this mess, okay? A whole bunch of gobbledygook, but you also get Berlin in exactly the right location. The odds are 309 million to 1. And all he did was use the first 11 characters in the upper left-hand corner and use the numbers that are right there in the plain text. That's unfathomable. That can't be a coincidence. That's far more impressive than arbitrary ELYOIE sightings that we all look for, going every two backwards on the something. It's crazy. So I'm buying this, and I think this is a necessary find, but it's not sufficient because obviously there's
This is a transposition of K4?
a transposition and a substitution. First, when he was decrypting,
Right,
he did the substitution first and the transposition, so the encrypt would be the opposite.
right.
Well, so everybody gave up.
Overheat.
It's overheating again.
Okay.
Everybody gave up, but I started coming on to it, and I said, let me just see if I can wave my hands. This is unfortunate. 'Cause,
Take your watch off, maybe it's shutting it off, like she's.
Yeah. Not the projector's
I think
overheating.
It's overheating is what it says.
Yeah. So and you know what? I'll even look at this and try to wave my hands because I can still see it
Put
here.
the thing right on top of the Coke can and see if that makes any difference.
Okay, on
Use
top.
it as a heat
Put
sink.
a can on top. Yep.
mean
On
the
a
can on
nap-
top thing?
Yeah. Put a napkin.
Wherever,
in
On
it.
top of
whichever
the-
way it balances.
On top of this, your device.
The only thing it's touching is cold.
How long till the Coke gets hot and goes?
Picture here, if you want.
Maybe gone by then.
Okay, you know what? I think I just have to try to wave my hands.
Yeah.
But there's a lot of good math here all of a
Okay.
sudden.
Remember
And so-
what Ed Shake said
so
about
basically-
Coca-Cola?
Basically, here's what I did. I decided to work it backwards and find out, now that we had Berlin in 64 through 69, I decided to do the would-be encryption implied by Scott's method and find out where those characters came from in K4 and what they matched up with when he did the substitution.
Okay,
The 6 characters in the Ima Furzelmut,
Right.
which 6 characters, and how that was interacting and bouncing around. Basically how the transposition and substitution are interacting.
so I just want to make sure I understand. So you started with the first letter in K1, counted 77, took a letter, counted another 38, took a letter, counted
Keep
another
doing-
77?
No, 38. 38 is the stride.
Okay,
77 is a one-time offset.
okay, so what were
Okay.
the 6 ciphertext letters that generated Berlin?
Okay, so what that lined up with, and this was very, very interesting, the B lined up with the M, which would be the second letter
K2.
of the 11. Okay, there were 11 characters, right,
Okay.
that he's using as a key.
Okay,
The B matched up with the second character in that string of 11, which it happens to be the M. But the
Another
letters
M.
aren't important. Let's go with the numbers.
okay.
Okay. So it lined up with the second character. The E lined up with the 7th. Okay. And then the R lined up with the 3rd. The L lined up with the 8th. The I lined up with the 4th. The N with the 9th. And it's interesting, you got the 2, 3, 4 kind of interleaved with the 7, 8, 9. 2, 7, 3, 8, 4, 9. And I look at this and I see if we're base 11, which we are in this case, as you're stepping through this substitution, you go from the 2 to the 7, you're adding 5. You go from the 5 back to the 3, you know, wrapping around, well, you had to add 7. So it's going 5, 7, 5, 7, 5, 7. Well, guess what? If you decide instead that you're going to just chop off the E and the A off the N and just keep the central 9, the muffpzlor, you know, if you just keep those and you find a way to get, now let's say you're going forward again. You got Berlin in 64 through 69. If you can find a way to do one encryption where you spread them out by 5, okay, so you might have a matrix of width 5. If you can get them spread out by 5 and then just hit them with the central 9 characters, you're going to find that Berlin hits exactly what you want it to. It'll hit the M, then the Z, then the U, then the L, then F, then R. So you would have the right, at least they would match up and do the substitution right. I wish I could show you
Yeah,
this.
I'm lost, so.
Yeah. Well, let me try to.
Did you want to email it to some of us for our smartphone?
Have you pushed
You know
this
what?
one?
I brought my laptop too, but by now it's like too late to really worry about that. Let me just say this, that Scott's implied encryption was what I'm calling a skip encrypt using a stride of 38 with an offset of 77. Those are the degrees right on the sculpture. But that's not practical to actually do it that way. You're really going to look for matrix techniques. Nobody's really going to count these things, you know, when you're encrypting or decrypting. And then a Quagmire 3 using those 11. I think Ed's custom process, aka possible masking technique, is you take your plain text and first you do a transposition that's going to spread Berlin, the characters of Berlin, out by some amount X. In the case that I showed, 5 that I was talking about earlier. Other things will work, but 5 in that case. Spread it out by 5. And then do a Quagmire 3 using a subset of the EMUF string that's appropriate for that X. And then do another transposition with your goal being that the resulting spread on Berlin is exactly 38. And then look at it at the end and say, I want the 77 too. I'll just do a little rotation at the end. So you have a transposition, you got a Quagmire, and you got another transposition. The good news for you is I had that figured out or thought about by the time we had the last dinner. Since that time, I sought to understand matrix methods like columnar transpositions, route transpositions, rail fence transpositions, and all their inverses. I studied Quagmire substitutions and varying keyword links, how they interacted with transpositions. I found entire families of possible methods and possible paths that would generate this same illusion, where I could do this matrix, this Quagmire, this matrix. I get Berlin where I want it, and it also, if someone were to try what Scott tried, or what maybe you wanted us to try, but we never tried until then, the Berlin would show up in the right spot either way. I did not just try stuff. Do you think Ed couldn't or wouldn't do this? I think it would be trivial and fun for you to do something like that. So I call that the Berlin families, but I have a favorite family member that I wish you would see. My favorite family member is if you rotate K4 one character to the right. So you take the R that's at the end, the K card, you take the R, you put it on front. So you have ROBKR. I'm going to tell you another step in a minute, but I like to interweave the clues there, the reason why I like this family member. Maybe that's the reason for the question mark in front of K4 saying, hey, does it really start with OBKR? You might need a rotation. So just a possibility. Step 2, so you take what came out of step 1 and you put it in a columnar transposition decryption using 5 columns. Okay, 5 columns. And you enter it using the key, if you're writing this down, 13524 at the top of the columns. Okay? And if you do that, so columnar transposition, right? You put them, when you're doing a decrypt, put it down the first column, then down the next column, down the next, down the next, down the next, until it's all filled out right. But you do it according to the key that I just read off. And so that's the step 2. And I wondered, is this the reason for the conspicuous 0.5 found in the coordinates at the end of K2? I mean, we don't have any fractions or any decimals except for that one thing. There's a 5 sticking out there like a sore thumb. Maybe that's a clue, because with columnar transposition, the real big thing is how many columns. Okay, so you might want a clue out there. So you do that, and then the third step, you take, so now you've done your rotate, you've done your first transposition. Next is the substitution, and I use the nine characters of, so from characters 2 through 10, the upper left-hand corner, and do a Quagmire 3 decryption. And why I like this is, if you look at that model of Kryptos right there, and you look at the characters that are all wacky in K3, and people talk about YAR, right, being so important, I think people are latching on to the fact that YA and R are superscripted, but nobody's really noticed that all those characters are, all the way from 2 through 7, 8, or 9, or 10. Some are those 3 are superscripted, the D is subscripted a little bit, and the others are kerned left and right. None of them are correct. This could be steganography saying, okay, you've got these 11 characters up here now that you're trying to solve Ed's puzzle. Which characters am I supposed to use? Well, you got your steganography right there telling you, don't use all 11, try these guys. I don't know, just a thought. Finally, the last step of my favorite family member is you perform a rail fence transposition. Rail fence, everybody know what that is? You write your, if you're doing an encryption, you write your plain text down in diagonals, okay? Looks like a bunch of W's or M's depending, and then you read off by the rows. And in a decryption, of course, you do the opposite. Put things back in by rows, read it off along the diagonals. Well, wouldn't you know it, if you pick a rail fence transposition with 25 rails, 97 characters fills up a perfect W. There's no extras. You don't have to keep it. It just comes up to the end. Perfect W. Where have we seen W's
many rails?
before? 25 rails. Yeah, is this the reason for referring to William Webster as WW? Just to get you in your mind, wow, that kind of looks like a rail fence transposition. Maybe I should use that. And if you do it, and if you saw it, you get Berlin exactly where it needs to be as you go down and go count. If you do those things. The problem? It's still gibberish. And clock doesn't show up, nor does anything else. So here's where I had to say, okay, Jim, and here I've got exactly what it says after you do those steps. I think that this method or some similar family member is what Ed intended. I think he had a concept of transposition, substitution, transposition. It's Ed's custom method, and here's a masking technique, because it's going to break the periodicity, that's going to make it harder to solve the substitution, and you don't have the English, so the transpositions are hard too. So we've got all these clues, especially the Berlin clue, if you happen to discover what Scott discovered, which we didn't discover until long after we were given the Berlin clue. Here's what I think is the problem, though. I think that Jim did add something more to stump Ed. Berlin clock encryption? What the hell would that be? More transposition? So now I've got a new model. Take the plain text, do Jim's custom process that even Ed doesn't know, pass it through Ed's custom process that we can only guess at, and you get the ciphertext. If that's the true pipeline of events, we're in a real world of hurts to solve that, especially if we can't get any acknowledgement from the only guy that knows kind of halfway there. So I've been working on finding clues to Jim's custom process. And one thing I thought is, okay, if Jim said, I can't screw up what Ed's done, whatever I do to K4 plaintext as I'm encrypting needs to keep Berlin there and also unmodified, so that Ed's ideas about how to make all this stuff, this illusion appear, still hold. So what kinds of things could Jim do to keep Berlin unmolested? And I came up with, you know, there's these different transpositions that move some things around but keep other things in blocks of text. And then also, if you don't want to change the substitute, you don't want to do substitution and screw them up, well, maybe you get a bunch of K's there, right? I can transpose everything, Berlin stays fixed, I can substitute everything, and if I have a bunch of K's, then those don't get changed. So I said, well, if that's true, then it's likely true that some other characters didn't move relative to one another, and other characters have similar key letters lined up with them. So I'll just take this gobbledygook and I'll just do a quagmire substitution on it with all A's, then all B's, then all C's, and see if any words pop out. And they did. When I do a quagmire substitution,
Quagmire 3 or 2?
quagmire 3, with all F's, the word bulb comes out. I thought that was pretty relevant to Berlin clock if you study the hit bulb.
4-letter word.
Only four-letter word. So now we're playing with numerology, right?
Yeah.
It may not be, but it's bulb.
Okay.
It's like the Berlin clock, and he said, study that history. Okay.
It's in the right family, like Girasol on the one here.
Yeah.
It's light.
I also found gold, wishful thinking. Wow, he's got a treasure map. I also found hands and hour, and that's also relevant to clocks. But then there was another one. I also did skip decrypt, something similar to what Scott did, and this was with a computer. Try a bunch of different strides through there, and then do quagmire decryptions with all A, B, C, hunt for words. And when I did a skip decrypt with a stride of 79, or minus 18, which is the same thing, and you got 97 characters, easier to deal with minus 18 and come up with a matrix for that. If you do that, and then you hit it with all Q's, 11 characters in a row said Doyle's back. And then I said, well, what would that have to be Doyle's book? What would I have had to use if it were, for the key? And it was 1, 2, 3, 4, 8 Q's, a V, an X, and another Q to say Doyle's book. And if you look at that cheat sheet that Jim had, the second row has an arrow going the other way, and there sure are a hell of a lot of Q's and a V and an X up there as well. Maybe he did it again. Maybe he did something similar to what you did, not trying to step too outside the bounds of what he understands. That could be numerology too. The reason why I asked about David Doyle, and I brought the books with me. David Doyle wrote a book. He was writing a book in 88 or 89, and it came out and it was actually published in 90, and it was called An Accurate Watch. Once again, relevance to a clock. Maybe Jim met David Doyle and talked to him on the side a little bit. I don't know. I don't know if I'm getting anywhere near Jim's custom process.